Okay, a little bit of information. I was being kind of a doofus and accidentally let the KSP run in the background, but as you see, we've cleared about 125 meters since the last video. So yeah, what we're doing here is we're getting close. Yeah, now you can actually see what I'm doing when I burn now. These guys aren't really lined up with each other, but that's not so big of a deal. So I don't know. Yeah, one thing I highly do not recommend is playing Kerbal Space Program when you're drunk. I tried that. Oh God. No, 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 no. You need to slow down. All right. As you see, when you start getting close, you can actually just kind of eyeball it, which is what I like doing. Because it's that rather slapdash approach to space travel. Alright. Too much altitude. Come back down a bit. Honestly, this video is the shortest, but it's probably going to be about the best. So yeah, you see I'm still a little bit higher than it, so we're going to pop down. And you'll notice in my other video I commented that I was at 1981, and I'm still at about 1981 throughout this whole thing. I don't really change my hello. It's not good. I don't really change it that much, so what we're gonna do is slow it down, bring it back a little bit. I'm gonna have to bring it up a bit. Alright, that's enough up. So we're still moving back, which is good. Oh. Now, the key to this is little movements now. Alright, 2.6. When these guys are less than 2 meters away, that means that their fuselages are within a meter of themselves. So we're going to go for 1.5 meters away. Or not. But yeah. So let's bring it down just a bit. Now, as you see, every time I do that, I move forward a little bit just because of my orientation to the orbiter B. So there we go. Yeah, that's a pretty successful meeting. Jeb and his crew are probably waving out the window at, well, no, not yet, they're not. Now they are. Waving out the window to Hernard and his crew. So now you want to be a little bit careful. I'm going to roll back up to normal so that I don't accidentally run into the orbiter B. Now what we're going to do is we're just going to... Now that wouldn't really affect that orbit too terribly much. As you see, I'm just barely pushing away from it. So now the other thing that we're going to want to do is we're going to want to get down underneath it. And you know, that's good. I mean, you don't really have to be too terribly precise now. What we're going to do is we're going to roll. Or I guess course correct to 270. Now, as you see, the orbiter and the orbiter B are very, very close to each other. So what we're going to do is we're going to burn, which will actually bring out my my orbit. You can actually start to see it now. Now, I don't really have to be too terribly precise on this, which is what I like. So long as I'm burning away, we're good. Now the other thing we're going to see when I pop back here is that the orbiter B will actually look like it's zipping away something fierce. So let me just get down to my preferred entry altitude of roughly 30,000. Now I like to be about as exact as I can be on this. Good enough for me. Now, as we see, this sucker is going away from us a lot faster than it was coming to us. Now, if I zoom back out, I can actually see the orbiter B still moving at 180.6, or I'm sorry, 1980.6, 1980.4. That's the variance between the apoapsis and the periapsis. So, I mean, if you stopped watching this video here, I would understand, but what we're going to do is we're going to speed this up. Not really worry about our end-over-end flipping, but this is just kind of a demonstration of it. Well, what I do is I let myself get within about 100,000 meters before I jettison the all the equipment that's been keeping the ship moving and alive. Now you'll see I have excess fuel, which yeah, that's actually pretty good. If you can splash down with extra fuel in your tank, you're doing something right. So there went the decoupler, and these guys are now, if I didn't do something right, screwed. But reentries I'm actually kind of boss at. Now the question is, where are they going to hit? An overland. I really don't like those because, as you see, it's not really affecting it because the apoapsis is staying consistent because I'm at 86,000 meters. Now the atmosphere really doesn't start until around 68,000. I'm not exactly sure where it is. All I know is 70,000 is above. So if you look at the orbital speed down on my nav ball, I'm actually picking up a lot of speed still, but I'm losing altitude, which is consistent with an elliptical orbit with a periapsis. That is actually a good deal different than the apoapsis. So in about 6,000 meters, we're going to hit the atmosphere. Now, it's not going to be a brilliant, whoosh, bang, whiz sort of thing. We're not just going to slow down. In fact, we're still going to be speeding up until we hit around 48,000, and then we do some really rapid deceleration. But, alright, see, we are in the atmosphere, but it's incredibly light. The capsule is still picking up speed, but as you see, we're actually losing altitude on the apoapsis because we're not picking up as much speed as we should. So we are slowing down. It's just the acceleration may be negative, but the velocity is still positive. So you always want your flat side facing the direction of travel, and I like to keep it upright. So as you see, we're still speeding up, but you can also see not as much as we really should be because we're actually down 3,000 meters from when we started. Now I know you're thinking, but Kyle, we're going to be flipping around outside and we're going to keep coming back. Not so, actually, because like I said, as you see on the orbit speed, we're slowing down a lot on the acceleration, which is what matters here. You need your acceleration to be negative, but not so crushingly negative that it liquefies your crew, which I really, really wish they would incorporate the G-force into that. But yeah, here we go. Our velocity is actually going to start rolling back now. And when your velocity starts actually rolling back is when you start losing a lot of altitude. So, yep. and we're still zipping along pretty good here. Just remember to keep your nav ball heading against the direction of travel, so that that flat surface is taking all of the damage. Or not really damage, but force. So, as you see, our periapsis is dropping dramatically, and our apoapsis is not even near before. In fact, we're well within inside the orbiter B debris range, which I like to think of as kind of an honorary thing, or a memorial to the people who died in order to bring them back. Which I'm not sure if that makes me a terrible person or not. So, yeah. My hopes for this video being shorter are not probably going to come true. However, I'm just glad that I can put these on YouTube, and I'm really kind of impressed with the Kerbal Space Program as a game. Actually, a few months before I heard about the Kerbal Space Program, I was programming a space race game. Just in my free time. It was absolutely nothing like Kerbal Space Program, and it didn't really work that great, but besides that, it was alright. But as you see, we're decelerating at a crazy fast rate, but our G-force is still minimal, because the G-force responds to jerk, which is the change in acceleration, not acceleration itself, which is why I call shenanigans on the movie Armageddon. Well, actually, I call shenanigans on a lot of things from that movie, but I don't really question it, because where else do you get to see Bruce Willis blow up an asteroid? Spoilers, I guess. You know what? No spoilers. That movie is old. In that movie, the Twin Towers are still standing, so yeah. Now we're coming in to the point where I'm going to want to start thinking about deploying parachutes in there's the debris we kicked out. I'm going to want to start thinking about deploying parachutes. Now I do that at one of two places. I do it at either 200 meters per second or 5,000 meters above Kerbin, which the two usually line up pretty well, especially if I'm doing this kind of re-entry. So, yeah, as you see, our jerk is still not that great, but we're actually slowing down with our acceleration to the point where I'm pretty sure we would hit terminal velocity, which I've always found that really fascinating. Terminal velocity, the fact that if a spacecraft came in and did what we did, it would actually slow down until it reached its optimal speed. So, yeah, now we're about 30 football fields in the air. 25. 20. 15. 10. 9. 8. 7. 6. 5. It lied. We are not that high from the ground. 4. 3. 2. I'm sorry. 2. Yeah, 12.8. You're really turtle stepping it to the ground. 1. Now, I know I didn't really do all the calculations to actually land in the ocean, which I normally do. I burn over that thing that looks like India, which generally puts me by the Space Center. But yeah, so that's how you do from launch pad to rendezvous to touchdown. We're going to go ahead and give you guys some closure and the flight. 8 hours, 28 minutes, 31 seconds. Covered 44 million miles. Or meters, I'm sorry. And we only encountered 2.5 Gs. So, hoorah, that's pretty good. So, yeah, this is that one guy signing off.